Welcome. So you've got a brand new Cisco router or switch, and you're probably wondering, what now? Well, in this explainer, we're going to walk through those critical first steps. We're going to take that blinking box and turn it into a secure, functional part of your network using the most essential commands. Let's get right into it.
I mean, really, think about it. You've just unboxed this new piece of gear. Right now, it's pretty much just an expensive paperweight. It can't connect, it can't route traffic, and it's definitely not securing anything. The magic happens when we jump into the command line interface, and that's exactly what we're about to do.
Here's our game plan. First, we'll cover the first 5 minutes, just getting connected. Then, and this is crucial, we're immediately going to lock it down. After that, we'll give it an address so it can actually talk to other devices, set some basic traffic rules, and finally, we'll make sure all our hard work doesn't just vanish after a reboot.
Okay, first things first. Before we can do any of that cool network management stuff, we need a direct line in. This initial console connection is your absolute lifeline, especially if the network goes down later. So let's get plugged in.
It all starts by connecting a console cable from your computer to the device's console port. Easy enough. Then you're going to fire up a terminal program, something like PuTTY or Terraterm. Once you've got that running, go ahead and power on the device. You should see a whole bunch of text scroll by, and then you'll land at a command prompt.
Now, this is really cool. The prompt itself tells you exactly what your access level is. You'll start with that little greater than symbol, the V prompt. That's called user exec mode, and you can't really do much there. Type enable, and you'll jump into privileged exec mode, which has the # or hashtag symbol. Here you can view settings, but to actually change things, you need to type configure terminal. That gets you to global configuration mode. So always keep an eye on that prompt. It's your guide to where you are.
All right, we have access. The very next thing we need to do, our absolute top priority, is security. An unsecured device is just an open door on your network. So we're going to build our first line of defense right now.
Think of these 5 commands as your security starter pack. First, hostname gives the device a unique name, which is super helpful. Then, enable secret protects that all-powerful privileged mode with a strong encrypted password. Next, we secure the physical console port and the virtual VTY lines, which are used for remote access like SSH. And finally, the banner MOTD, or Message of the Day, gives a legal warning to anyone trying to log in.
You know, this is a simple but really powerful security step. By default, some passwords are stored in plain, readable text. You can see it right there. But if you run the command service password encryption, it applies a basic layer of scrambling to them. Now, it's not Fort Knox, but it's a huge step up from having passwords just sitting there in the config file for anyone to see.
Okay, our device is secure. Now let's actually get it on the network map. For this thing to be useful, it needs an identity, a way to be found, and a way to communicate. And in networking, that identity is its IP address.
The easiest way to think about an IP address is to compare it to a street address for your house. It is a totally unique identifier on the network that tells data packets exactly where to go. Without an IP address, the device is basically on its own little island, unable to forward any traffic.
So getting an interface online is a 3-step dance. First, you have to tell it which interface you want to configure, like Gigabit Ethernet 0/0. Second, you assign it an IP address and a subnet mask. And third, and trust me, this trips everyone up at first, you have to actually turn the interface on with the no shutdown command. By default, they're all off.
So how do you know if it actually worked? Well, let me introduce you to one of the most useful commands you will ever learn. Show IP interface brief. It gives you a perfect, quick summary of all your interfaces, their IP addresses, and most importantly, their status. What you're looking for is up in both the status and protocol columns. That means everything is healthy.
Our device is now officially on the network, so our next job is to act like a security guard, deciding what kind of traffic is allowed to come in and what's allowed to go out. To do that, we use something called Access Control Lists, or ACLs. An ACL is pretty much what it sounds like. It's a list of rules, in order. Every single packet that tries to cross an interface with an ACL gets checked against that list, from the top down. The very first rule that it matches determines its fate, whether it's permitted to pass or just dropped.
Let's just break down one of these rules so it's not so intimidating. Access List 101. That's just the name of our list. Then we tell it to permit traffic using the TCP protocol. The source and destination are both set to any, which means from any network to any network. But here's the key, EQ80. That means equal to port 80. So this rule is specifically allowing web traffic through.
Now, this is the final and most critical piece of the ACL puzzle.
An ACL does absolutely nothing until you actually apply it to an interface. You use the IP access group command, point to your list number, and, this is important, you have to give it a direction, in for incoming traffic or out for outgoing.
We have done all this great work. We've configured security, interfaces, and rules. But right now, if the power goes out, all of it is gone. Poof. Let's talk about the single most important step in this whole process, saving your configuration.
Here's the deal. Everything we've done so far exists in what's called the running config, and it lives in RAM. RAM is volatile, which is a fancy way of saying its memory gets erased when the device loses power. To make our changes permanent, we have to copy them over to the startup config, which is stored in a special type of memory called NVRAM that doesn't forget.
This is it. This is the command that makes it all permanent. Copy running config startup config. It does exactly what it says on the tin. It takes the current active configuration and writes it to permanent storage. Now your settings will actually survive a reboot.
And hey, you don't just have to take my word for it. This is a direct quote from Cisco's own documentation. It is the golden rule. Make saving your work a habit, and it will save you a world of headache down the road. So there you have it. In just a few steps, we went from a useless box to a secure, configured, and saved device that's ready for the network. But honestly, this is just the beginning. The world of networking is all about constant monitoring, maintenance, and learning. So the real question is, what's the next step you would take to build on this foundation? Thanks for joining me.